astronomical navigation, the azimuth of the sun at sunrise or sunset. Why do we need the azimuth? We can use the azimuth for a determination of the error of the compass. This short video is about the formula you can use for the calculation. Let's start with the sphere. The sphere, here we see the equator of the sphere. Here you see the sphere itself. Make it a little bit longer for later on. And in the middle of the sphere is the Earth over here, like this. Well, here the sphere is actually the place where all the celestial bodies are projected. Say on the sphere we have our own position, and say this is the North Pole. We have here the meridian of the observer, and say this is our position here. We can record it as a dead reckoning. On the sphere we have the meridian over there, and we can plot the point T, which is the top point over there. So knowing that this is celestial North Pole, we have the point T. Giving this here is the latitude of the dead reckoning. On Earth you can say it's this angle, and so from P to T would be 90 minus the latitude. Then we're talking about the sun. Say that at sunrise the sun would be somewhere here in this bearing. As the Earth projection. We can make a meridian over here, center of the Earth projection, and here would be the point S, where the celestial body is projected on the sphere. That would mean that this is the declination, and here we have 90 degrees minus the declination. Now we go back to our position. We are here on Earth, and looking upwards we see point T, the top point, and with that information we can construct the local horizon. Now say the local horizon is here, perpendicular to the line from the midpoint Earth to T, and here is the local horizon. Okay, if I have a circle segment here, we know that this from the horizon to the point S would be the height of the body, in this case the sun. In the triangle this would be 90 minus the height, because from the horizon to T is a 90 degrees, because T is the point when you look upward. Okay, now we have a celestial triangle with here the local hour angle. Okay, now we can start our calculations. I take out the triangle. It looks like this point P. This is the angle T we're looking for. Point S, 90 minus the height, 90 minus the latitude, and 90 minus the declination. Okay, so applying the rule of cosine in triangle PST, we would get something like the cosine of PS, which is opposite to the angle T, is something like the cosine of PT, the side adjacent to t, and the cosine of st, added by sinus pt sinus st and the cosinus of the angle t. Actually, we're looking for this t because that's necessary for the azimuth. Okay, filling in the things. Cosinus pi s. Well, I had the cosinus of 90 minus the declination when you look in the drawing. It's this one here. Okay, having said that, cosinus 90 equals the sinus of the declination. Is the cosinus of pt, 90 minus the latitude, equals the sinus of the latitude, times cosinus of st, 90 minus h. Well, that would probably be sinus of h. Well, likewise we can fill in that this would be cosinus of the latitude, cosinus of the altitude, and cosinus of the t. Well, at sunrise, and that's the same for sunset, we know that the altitude above the horizon is 0. Okay, from that we can derive that the sinus of h would be 0. So this is a 0, so this whole part of the formula can be skipped, and the cosinus of h is 1, which we will fill in over there. We get the following formula: sinus of the declination equals cosinus of the latitude, cosinus of the azimuth, and now we can say the cosinus of t is the sinus of the declination divided by cosinus of the latitude. And this is the formula with which you can calculate the azimuth. Now, of course, we should, based on, say, the local hour angle between 0 and 180, we would say that the t is 360 minus t, so we have a t exempt. But skip the thing. When you're on board your vessel, you calculate the t, and you actually know that the sun will rise somewhere in the east, so you can subtract 360 or whatever. Okay, so use this formula for calculating the azimuth, and we have an example of that in a next video. Thanks for watching.